Good morning, everyone. Today, in our last lecture, we have completed up to the uh, uh, plane polarized light. Today, we'll start with the angle of rotation. So, what is angle of rotation? Very simple. Very simple. Let us consider a molecule. Very simple. The light is coming and it is reflected. Now we change the molecule by some angle. Then obviously the incident angle will change and the reflected angle will also change. Again, if we change the angle of rotation, the incident angle will change and the reflected angle will change. Obviously, it will remain perpendicular. So the angle at which the molecule is rotated to obtain the maximum intensity of the emergent means reflected radiation. It is known as angle of rotation. So we have to rotate the molecule by some angle to obtain what? The maximum intensity of the emergent light. That is known as the angle of rotation. Now we are proceeding to the Biote's law. Let us consider a liquid molecule. Let us consider a liquid molecule. It is kept in a container of thickness, length L. The light is coming and it is reflected. Let us consider a liquid molecule. It is kept in a container. The name of the container is polarimeter tube. The length of the container is L. And the molecule, every molecule has a concentration. The concentration of the molecule is C. So what is the Biote's law? Angle of rotation. It is proportional to what? The length of the polarimeter tube and concentration of the molecule. What are the constants here? So the constant here is temperature and the wavelength of light. So at a constant temperature and a constant wavelength of light, the angle of rotation is proportional to the concentration of the molecule and the length of the polarimeter tube. So alpha, it means angle of rotation. It is proportional to L. L means length of the polarimeter tube. And C means what? Concentration of the molecule. So in order to remove the proportional, we have to give a constant. So here constant is alpha lambda to T LC. So what is alpha lambda to T? Alpha lambda to T. Alpha lambda to T. It is known as specific rotation. So in order to remove the proportional, we have to give a constant. The constant here is alpha lambda to T. Alpha lambda to T, it is known as specific rotation. So now we are going to the definition of the specific rotation. So again I am telling, the constant here is temperature and the wavelength of light. So at a constant temperature and wavelength of light, angle of rotation, it is proportional to what? The concentration of the molecule and the length of the polarimeter tube. So alpha is equal to alpha lambda to T LC. So alpha lambda to T is the constant here. It is known as specific rotation. Now what is specific rotation? Very simple. So we are alpha proportional to LC. Alpha is equal to KLC. So instead of K, we are writing alpha lambda to T. So alpha is equal to alpha lambda to LC. So alpha lambda to T, it is known as specific rotation. So what is specific rotation? So alpha is equal to alpha lambda to T LC. So if the length is 1 decimeter and the concentration of the molecule is 1 gram per ml, then alpha is equal to what? Alpha is equal to alpha lambda to T into 1 into 1. Alpha lambda to T into 1 into 1. This means alpha is equal to what? Alpha lambda to t. So what is specific rotation? Specific rotation is the angle of rotation of an optically active molecule having concentration 1 gram per ml. When it is taken? It is taken in a polarimeter tube of length 1 decimeter. And what are the constant? Constant is temperature and wavelength. So specific rotation is the angle of rotation of a what? Of a optically active molecule. Of a optically active molecule having concentration 1 gram per ml. Taken in a, where taken? It is taken in a polarimeter tube of 1 decimeter length at a specific temperature and wavelength. Now we are going to the factors on which angle of rotation depend. It depends on the concentration of the molecule. It depends on the length of the polarimeter tube. It depends on the temperature. It depends on the wavelength of light and also the nature of the solvent and sample. Now we are proceeding to the, so what are the factors on which angle of rotation depend? The factors on which angle of rotation depend, they are the concentration of the molecule, length of the polarimeter tube, temperature of the medium, wavelength of light, and the nature of the molecule and the solvent. Now we are proceeding to when the molecule is optically active. So we are taking a very simple example. COOH, HCl, CH3. Now how can we draw its mirror image? Just think, the top and the bottom. Just think of your body. Just think of our body. When you look to the mirror, the top and the bottom remains unchanged. The left becomes the right and the right becomes the left. Similar for the molecule. Similar for the molecule. The top and the bottom remains unchanged to COOH and CH3 remains unchanged. The left will go to the right and the right will go to the left. This is known as non-superimposable mirror image. Non-superimposable mirror image. So when the molecule produces non-superimposable mirror image, it is known as optically active. So again I am telling, when, very simple, when we look to the mirror, our top and the bottom remains unchanged. Left hand becomes right hand and right hand becomes left hand. Similarly for the molecule, the top and the bottom remains unchanged. The left side will go to the right and the right side will get to the left. So when the molecule produces non-superimposable mirror image, it is optically active. It is optically active. And so now we are proceeding to the next slide. So if the molecule possesses any one of the four symmetry elements, means simple axis of symmetry, plane of symmetry, center of symmetry, and alternating axis of symmetry. If the molecule possesses any one of these symmetry element, minimum any one of these symmetry element, then it is optically inactive. If more than one symmetry element are present, then it will obviously be optically inactive. Simple axis of symmetry, it is denoted by Cn. Plane of symmetry, it is denoted by sigma. Center of symmetry, it is denoted by I. Alternating axis of symmetry, it is denoted by Sn. So if the molecule possesses any one of these symmetry element, then the molecule is optically inactive. When the molecule possesses any one of these symmetry element, then it is optically inactive. Minimum more than one symmetry element, then it will obviously be optically inactive. Now, what is diastereoisomers? Just look at this molecule. CHO, HOH, HOH, CH2OH. So these two middle carbons, these are known as chiral carbon. These two carbons are known as chiral carbon. Now look at the B molecule. Just look at the B molecule. First chiral carbon is interchanged, but second chiral carbon remains unchanged. So B is not the non-superimposable mirror image of A. Just look at A and B. So for B, the first chiral carbon is interchanged, but second chiral carbon remains as it is. So B cannot be the non-superimposable mirror image of A. B cannot be the non-superimposable mirror image of A. So the molecule which does not possess no mirror image relationship, they are known as diastereoisomers. Similarly, look at B and C. Similarly, for C, look at B and D. For B, the first chiral carbon remains unchanged, but second chiral carbon is interchanged. So again, D is not the non-superimposable mirror image of B. So A and B and B and D, they are diasteromers. The molecule which does not produce no mirror image relationship, they are known as diasteromers. Similarly, we are proceeding to the enantiomers. So what is enantiomers? So COOH, HOH, CH3. So this carbon is known as chiral carbon. Now, just look at B. The chiral carbon is interchanged because H goes in place of OH and OH goes in place of H. So obviously, B is the non-superimposable mirror image of A. So non-superimposable mirror image, they are known as enantiomers. Non-superimposable mirror image, they are known as enantiomers. So again I am telling, just look at A and B. For B, H goes in place of OH and OH goes in place of H. So obviously, B is the non-superimposable mirror image of A. So non-superimposable mirror image, they are known as enantiomers. Now we are proceeding to the symmetry element. So symmetry elements can be simple axis of symmetry, plane of symmetry, center of symmetry, and alternating axis of symmetry. So we are proceeding to the definition. So plane of symmetry. Here a complicated example is given, but we are taking a very simple example. COOH, HCl, COOH. So these two are the chiral carbons. Now, if we draw a plane through the middle, then obviously the upper part and the lower part are the same. So a plane of symmetry, just look at, the upper part contains COOH, HCl, and the lower part also contains COOH, HCl. So a plane of symmetry is a plane. What does it do? It divides the molecule into two halves such that the upper half and the lower half are equal. Just look at this example. The upper part contains COOH, HCl, and the lower part also contains COOH, HCl. So a plane of symmetry is a plane. What does it do? It divides the molecule into two halves such that their upper half and the the lower half are equal. Now we are proceeding to the center of symmetry. We are taking an example. It is known as alpha truxalic acid. Very simple example. COOH H pH H COOH and H pH. Now imagine this point. So from this point, if we draw a straight line, at the bottom we get COOH. Similarly, at the top we get COOH. Similarly, if we draw a point along the diagonal, at the lower part we get pH and the upper part we also get pH. So a center of symmetry is a point from which, if we draw a straight line, and also extended to an equal distance on the opposite side, then identical atoms will be found. Just look at this. At the top, we get pH. Similarly, at the bottom, we get pH. At the top, we get COOH. At the bottom, we get COOH. So, center of symmetry is what? It's a point from which what we are doing? We draw a straight line. And then extended to an equal distance on the opposite side. Then we get what? Then we get the identical atoms. This is the most important. And the most important example is alpha truxalic acid. So this molecule is known as alpha truxalic acid. Now we are proceeding to the alternating axis of symmetry. Again we are taking the example alpha truxalic acid. COOH pH HPH HCOOH. Now we rotate the molecule along 180 degree along the axis. So if we rotate the molecule along the axis, what happens? We get what? This will be HCOOH. We rotate the molecule by 180 degree. This will be HPH. This will be COOH H. This will be PHH. So we rotate the molecule along the axis. So if we rotate the molecule along the axis, then obviously just look at the hand. If we rotate the molecule along the axis, then this is the hand, then it will become this. So this is HCOOH. This is HCOOH. Now we rotate the molecule by 180 degree along the axis. Then obviously it will be, this is HCOOH, so this will obviously be COOH. So if we rotate the molecule by 180 degree along the axis, then obviously COOH, it will become HCOOH. PHH, it will become HPH. HCOOH, it will become COOH. And HPH, it will become PHH. Now we are drawing its mirror image along the what? Along the diagonal. Along the diagonal. We are drawing the mirror image along the diagonal. So if we are drawing the mirror image along the diagonal, then again the molecule will be same as the original. So this will be COOH. H, PH, H, H, COOH, H, PH. So here the molecule is rotated by what? 180 degree. Then we carry out its what? Mirror image along the diagonal. Then we get the identical atom. So standard definition is the molecule will be rotated by 2 pi by n. N may be 1, 2, 3, 4 up to infinity. 2 pi means 360 degree. So 360 degree by n. And then we carry out its what? Mirror image along the diagonal. Then we get the what? Then we get the molecule identical with the original. The molecule is what? Rotated by 360 degree by n. N may be 1, 2, 3, 4, infinity. And then mirror image is carried out along the diagonal. Then we get the what? Then we get the identical atoms. So this is known as alternating axis of symmetry. So molecule is rotated by 360 degree by n. Then we carry out its mirror image along the diagonal. And then we get what? Identical atoms along the identical atoms. Then so it is known as alternating axis of symmetry. Now we are proceeding to the simple axis of symmetry. So this is very simple. We are taking a molecule, water. So rotation will be what? 360 degree by, very simple, 360 degree by, this is denoted by Cn. N means here number of equal atoms. Very mechanical. So for water, equal atoms is 2. So rotation will be 360 degree by 2 means 180 degree. So the molecule possesses what? So the molecule possesses Cn. N means here 2, C2. Similarly, chloroform. How many equal atoms are there? 3 equal atoms. So rotation will be what? 360 degree by 3 means 120 degree. So the molecule possesses what? So the molecule possesses C3. Now for benzene, how many equal atoms are there? 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. Rotation will be what? 360 degree by 6 means 60 degree. So the molecule possesses what? The molecule possesses C6. So in this lecture, we have completed the angle of rotation, Biot's law, and enantiomers, diastereomers, and about the axis of symmetry. In the next lecture, we will start the projection formula of stereoisomer. Fisher projection, Sohor's projection, Newman, and flying wedge. And after that, we will proceed with DLRS, Z nomenclature, and conformation. Thank you for your kind attention.